So those informations need to be encrypted and to be kept in the blockchain because they cannot be made in the public. Okay. So in that case, what will tell that, for example, a group of say hospital will be there. For example, Apollo, Ear Care or AIG, all these things, they will form some P2P networks, and there will be owner of this network, means these are the hospitals. They will decide which node to assign the access to, say, send, receive, join, or verify the block, say, for creating an agreement between other. And there are certain applications where we require something known as a consortium or hybrid blockchain. For example, one of the good example is known as the intelligent transportation systems. In case of the intelligent transportation systems, so most of the informations are topic related, they are public. Those informations can be put in the blockchain, but there will be certain informations which are very, very confidential. For example, there is a ministry accident takes place in the road. Those informations cannot be put in the public, they need to be encrypted and put in the blockchain. As a result, so based on the applications, either we can have the public blockchains, private blockchains, or some of the cases we can have the both one, that is known as the hybrid or consortium blockchains. Alright. So next question is that, so what is the structure of a block in the blockchain? Okay. So now let us look at structure in case of a block, in case of the public blockchains, in case of the private blockchain, in case of the consortium blockchains. So if you look at the first one, so just like your IP packet, we are having block header as well as block payload or transmission. In block header, what will have that? It will give the information about the blocks. You can have the block versions, which is the unique serial number or unique integers. Previous block as of the previous block. Then the market code, we will talk about what is the market code. It is some kind of balanced binary tree. And the hash value of all the transitions will be created in the market, and that hash value is along with the pointer to the whole tree that generated for the market. Okay, that will be also used. Then we are having the block type. If it is a public block, it will be public, private in case of the hybrid. Then we can have the timestamp when the block was created. That timestamp will be also created. Then the owner of the block, who is the owner of the block, who created the block. So that owner of the block will be also mentioned here. Then we are having the public key of the signer, and that public key of the signer is needed in order to verify the signature on the block. And in that case, you can use something known as the elliptic curve digital signature algorithm. So that algorithm will be useful for creating digital signatures, and also that public key will be used for verifying the digital signatures. Alright. So once we talk about the block payload, so block payload in context, you have something of the transactions. So transactions, for example, suppose 80 number of transactions are there, transactions 1, transactions 2, transactions. Because it is the public domain, for transactions need not to be encrypted, they are in public. Okay. So after that, we are having something of the current block hash. So what will do that? Hash of log headers as well as all transactions will do the hashing. For example, we will use the SHA-256 hash algorithms. Hash of log headers, all the fields, concatenation with all the transactions. So then we will get the 256 as output, and that will be put as the current block hash. So finally, we are having the signature on this current block hash using some public key based algorithms. Here, in case of the blockchain, they use the elliptic curve descriptive algorithm. So that's why we know that the elliptic curve digital signatures algorithm. They put it for creating the signatures. Now, in case of the private blockchain, if you see that the only the difference is that here the transactions, they are basically encrypted with the help of the public key of the owner. Because here the owner can only decrypt your information, and nobody can decrypt the information. So that's why that all the transactions they are encrypted using the public key of the owner. and owner can only decrypt the information. And other things are same, current blockage as well as signature on the block. And in case of your something known as the consortium blockchain, some of the transactions are encrypted and most of the transactions are unencrypted. Right. So as a result, so what we are talking about that, in order to verify a transaction or in order to verify a block, whether a block is valid or not, you require to verify the three things. So one is that you need to verify that something known as the market root, you need to verify it. If the market root verification is high, then you need to verify current blockage. And if the current blockage is fine, then you need to verify the signature. And if all these verifications are correct, then only this block will be treated as a valid block, and you can then save all the transactions for your big data analytics purposes using machine learning. Right. Now we'll come to this point, something known as the market root. So what is the market root? Is that market root is nothing but a balanced, complete binary. So for this purpose, what we require some transactions or data. So for example, transactions 1, 2, 3, 4, 5 up to 8 is there. So then what we'll do? At the upper layer, we'll do the hash of all the transactions. So hash value of the transactions 1, let me be calling it the hash 1, hash of the transactions 2, hash 2, and so on. So once we calculated all the hashes, in the upper layer what we do that we combine two hashes to get the hash of 1, 2. For example, what you can do that, to compute hash of 1, 2, you can do the hash of this hash value contains in this hash value. You can do it. So it will be computed in the hash 1, 2. So similarly for hash 3, 4 we will compute it and hash do the hash 3, 4, hash 5, 6, hash 7, 8. Now in the upper layer, so what we will do that again we will combine hash 1, 2 and hash 3, 4 with the confidence with the hash, we will get the hash 1, 2, 3, 4, hash 5, 6, 7. And at the top level, at the root level, we do the hash of hash 1, 2, 3, 4, hash 5, 6, 7. So what we are telling that root of the market tree root contains essentially the hash of, indirectly hash of all the transactions. Right. As a result, even if one transaction is say corrupted by the adversary, your market root value will be corrupted. Okay. So now let us look at how market root has been is used to verify transactions.
Sir, we take a tea break.
Yeah, after this slide. So for instance, say we are having say example of say 3 blocks, block 1, block 2 and block 3. And say in the block 2, we are having the 4 transactions A, B, C, D. We created this market tree and market tree value is put it here. So market tree root value is there along with the pointer to this market tree is also put in the block. Now the questions come that say you want to verify whether this block is correct or not using the market tree root, and then you confirm that whatever transaction is put in the block they are valid. Okay. So for this purpose, suppose that you want to verify in transactions Y whether this transactions Y is correct in the block or not. So then what you do? So note that you are having that pointer to the tree in the block also. So you have the access of the tree also. Right? So then what will do that? To verify a transactions Y, you simply compute the hash of Y. And without decomputing hash of Z, because hash of Z can be accessed to the root, you compute hash of Y. And without decomputing the H W of X, because you can access from the tree, you compute the root value H of W X Y. So once now you decompute the hash value, so what to do that? You now compare whether decomputed market value matching with the stored market value or not. And if it matches, you it confirms that your transaction is correct. Alright? So this is the use of the Markletti road, and it is the important use of the Markletti road where the transactions can be validated using this process. Okay, so we'll talk about after the period about this sequences algorithm. Alright. Any questions?
Go to 28, sir. 28. One more batch.
Previous, right?
Yes.
Okay.
Yeah. Here are transactions A, transaction B, and transaction C, and transaction D. Stored in a block 2. So can we store 4 transactions in a single block, sir?
Yes. For example, we are having say threshold NT, right? NT is the number of transactions to be stored in a block.
Yeah.
So for example, NT value is 100 transactions. 100 transactions, for example, you are creating transactions, you are putting in a pool. We will also talk about the consensus algorithms, how block is created. Once you hit the threshold value of threshold number of transactions, you create a block. Then the block is going to be mined in the blockchain. Otherwise, right? And one interesting property is that, and for each and every block, all the transactions are distinct. Or maybe some transactions may be repeated, but most of the transactions are distinct. Therefore, your objective value will be distinct for each and every block. Because of the hash property. Right?
Means more than one transaction can be stored in a single block.
Yes. For example, 100 transactions are stored in a block. For example, if you are having say video data, so one transaction may contain say 5 MB data. So 5 MB into say 100, you can store so many MB's data in the block. Right.
One thing is I want to
Yes.
from implementation point of view, most of the blockchain applications are proof of concept or prototype or schematic. So is it really a hype or is what you feel? Like whether it's going to be a practical solution for something?
Yes. For example, we have done here paper, we will talk about that. We have used practical budget control algorithm, PBFT. So which is
No, I'm not saying this one. I'm saying that for example, whenever we are implementing blockchain for a company, so either we have to go for private blockchain or consortium blockchain. So private blockchain is what I can say it's not a kind of blockchain, it's a fit definition.
Yes.
In private blockchain, everything someone is owning it. So basic principle of blockchain is not followed. Similarly, in a consortium blockchain, same things happen. And when we are implementing some big system, so can it be real distributed? Who is the owner? Who can own? Who can take decisions? So is it really possible in future also?
Yes.
We can implement it in a big system.
Yes. For example, we are running a project, something known as the Unified Blockchain Framework from Government of India. This is about 65 crores projects. We are part of that one.
Blockchain,
Yes.
I have heard the name, blockchain.
Yeah, we are implementing blockchain.
See, central blockchain excellence.
Yes. That is possible.
It's possible.
But what is that? It will require more energy. More cost is required certainly. But it is possible.
A lot of issues are time is an issue, scalability is an
So
issue.
that is the scalability is the issue.
Scalability is an
The
issue.
number of transactions process per unit time is your cost.
If we want to secure a blockchain, then we have to limit the speed of adding a block.
Yes, that is true.
So
There is some bottleneck or limitation is
So
there.
how can it be scalable? Scalability is a big issue.
Yes, scalability is useful, but still it is possible because once you are adding a block in the blockchain, you need not to do after that anything more. That is the one-time cost. Right? So therefore, of course, to use the blockchain, we can't use the resource-constant devices. All the devices will be high. Your cloud servers will be put in the peer-to-peer.
So apart from the proof of concept or prototype, is there any practical system that is totally based on blockchain? Because there is so many, all systems what we have heard about, these are prototype or proof of concept. So is there any real implementation that is?
Yes, yes, they will practice there. PBFT algorithms are there. RCT is there. Ripple protocol consensus algorithms are there. They are there. But again, your question is the scalability may not be last scalable as you think about it, but it is medium scalable already.
My expectation is like after some time may be just kind of high has been created in blockchain, after some time it will not be exist, something like that.
No. But once you put your data in the blockchain, data is secure. You want to secure them. For example, that's why we talk about in the next step that what is the AI-based security for using blockchain storage. That if you say store your data in the cloud, in cloud data your insider attacker can change your data. But once you are having the data in the blockchain, nobody can change that. It ensures. And of course, for that reason, that you need to sacrifice some, you cost other things. Where in the cloud you can directly store the data, but it is not in the blockchain. It requires some effort, but your data is more secure. Yeah.